Troubleshooting prefix lists. Here's your flyby on prefix lists, which I find most troubleshooting for prefix lists is just because people don't understand them. So prefix lists are an improvement on access lists for matching routes. So first off, put this thing in its place. This thing is for filtering routes, typically when you're doing redistribution or heavily when you're using BGP to match certain ranges of subnet masks and so on. So similar structure to an access list where essentially you create the prefix list with this list of statements, sequence, so sequence 10, 20, 30, and all that, saying permit this, deny that, permit this, deny that, but it has a two-stage matching system. This is where the differences come in. Instead of just saying, I'm going to deny the 192.168.1 subnet, we actually say, okay, I'm going to deny this subnet and then all the specific masks between the range that I specify. What do I mean? So for instance, one of the things that you'll have in the BGP world, so let's just say this is a BGP router of an ISP, is the ability to protect yourself from your customers sending all these little routes, right? BGP is awesome, but it's dealing with a routing table of millions of routes, well, hundreds of thousands of routes. And if you were to accept any route from anybody, it could quickly move into the millions of routes, and then you would have a performance crisis on your hands. So a lot of times you'll find out BGP service providers or service providers running BGP will say, okay, well, you know what? We'll allow you to advertise your subnet to us, which an access list can do, but then they'll say, but we won't allow any subnet masks more specific than maybe a /24 or maybe a /24 through a /25. If I can get my slashes right. You want to, give them some flexibility to do some subnetting and advertise those routes to you. So we'll look more at that, but that's the beauty of prefix lists. That's the whole reason that you use them. Now again, this is for filtering routes. This is not something you would apply to an interface to filter traffic going through it. It's prefix list. It's like subnetting. It will hurt your brain when you're first getting it, or even jogging your memory. I've had to relearn access lists 100 times as I've taught them, and it's one you use rarely unless you work for a service provider or deal with them on a frequent basis. So it's some of those concepts that you have to constantly relearn. So the best way to learn prefix lists or review them is to look at examples which will jog your memory. Global config mode, you can go in and type in IP prefix list to create it. Put a name in there. I just put JC. Permit, and then we've got what we want to permit, followed by any subnet mask parameters. I'm starting it simple, just saying, okay, if I were to type this and press enter, it would take that. It's a valid command. What would it permit? The answer is this guy. Nothing more, nothing less. Which is weird if you have the access list way of thinking, because you're like, oh, well, /16, I mean, doesn't that permit all the subnets of it? No, it does not. That is a specific match, so this guy, this guy, this guy, none of those match because it's not specifically that. So let's tune it. We type in IP prefix list, JC, permit, same subnet, 172.30.00/16, LE20. Just remember that thing stands for less than or equal to 20 bits is what we're after. So again, we're matching a two-stage system. So let's look at this guy. This guy comes in 172.30.10. Does it match this first piece, right? It doesn't match 172.30.00/16. You could say yes, it does, because it's a subnet or a derivative thereof. And then we say, okay, well, does it match the second piece? Is it subnet mask specificity less than or equal to 20 bits? At which point I would say, I'm afraid it's not. It's greater than 20 bits. It's 24, so that one does not match. This guy does, because it would pass check number 1. It says, okay, it is 172.30.00/16. And its subnet mask is less than or equal to 20 bits. So, yes, that one's allowed. How about this guy? 172.30.32.0 comes in and says, okay, I am matching, I am a derivative of 172.30.00, right? It falls underneath there. And my subnet mask is less than or equal to 20 because I have a /19. So this one would be permitted through. Now, again, when I'm saying permitted through, maybe this is a bunch of VLANs. Maybe this is another router that's redistributing these routes, and I'm saying I'm going to filter these so only certain routes can pass through this router to the other side and pass on, right? That's an example of what we would do. This one, /18, so it falls under that less than or equal to, but it fails check 1 because it's not 172.30, it's 172.16, so that does not pass through. This guy's got the same problem as the first one, is A. It falls under this, so it passes check 1. However, it does not have a subnet mask less than or equal to 20 bits. Okay, let's change the story. You getting the idea? IP prefix list JC permit 172.30.00. Now I've swapped in GE. So greater than or equal to 20. Running through the same list, this one, pa-ching, passes because it's a subnet, and it now has a subnet mask greater than or equal to 20 bits, right? It's 24, so that one goes through. This guy, okay, this one does not pass. Okay, this throws a lot of people off. They're like, what? What's going on? Because it matches this exactly, cha-ching, but its subnet, it fails check 2. Its subnet mask does not pass the greater than or equal to 20, right? That's where a lot of people fall off the boat. They're like, it does not compute. Always remember prefix lists as a 2-check system, right? So, how about this third one? 172.30.32 does not pass. Passes check 1, fails check 2. This one, fails check 1. This one, ching, passes through. It passes the check 1, and its subnet mask is greater than or equal to 20. It's a /24. You getting it? You getting that feel of prefix list? Now remember, you can add in here. You could do, I want to do LE, well, we could do greater than or equal to 20, LE22, right? To really box it in, to say I want to allow things from 20 to 22 bits in length, but I don't want the /24s. Again, you can get super specific and expect to see those kind of things on a T-Shoot exam. So what can go wrong with prefix lists? Well, a lot of it's just like I said, not understanding the matching mechanism. For instance, you maybe would go in, let me just go into the router and do IP prefix lists, and you say, let's do, ASDF. And we'll say permits, and you do that exactly what I was showing, 172.16.0.0/16. You're like, okay, that should allow all of them, right? Yeah, no GE or LE, only permits specifically that route and exactly that route, none of the subnets to it. So you always have to come in there and say, okay, I've got my GE, 24, my LE, we'll just say 30, I don't want anything more specific than that, and putting them in the right way. So mistaking what is GE, forgetting that E equals to. So you might think, /23 is needed rather than you know what I mean, right? Sometimes people are like, it must mean greater than 24, not including 24. So those mechanics, that's a huge part of what can go wrong. These things do have immediate execution when they are applied. So you might have this thing sitting applied to an OSPF filter, right? Redistributing OSPF into EIGRP, we'll just say. and you apply it and then start adding statements to it, well, as soon as you do, you get that implicit deny, and that destroys all of your routes, right? You've got essentially a fortress going around your route redistribution, and nothing comes through. So you could take a network down easily by doing that. Of course, prefix lists were designed by access lists using that format, so applying them the wrong direction, understanding that they do top-down processing, and as soon as they hit the first match, they stop processing, implicit deny at the bottom, all those same kind of things apply in this case. So we can come in and do the verification, do a show IP prefix list, and that will show us all the prefix lists that we've created and the sequence numbers therein. You do a show run and include IP prefix, or just IP pre, go short, and see the exact commands you've typed in to make them, or you can look at the route map, and I don't have a route map on here, but you typically apply these things to BGP or other routing protocols by embedding them inside of a route map. So do a show route map and make sure that it's applied the right way. So that's what prefix list troubleshooting is all about. I hope this has been informative for you, and I'd like to thank you for viewing.